Hello everyone, my name is Perez, and I made this video as a presentation for my senior project. So to begin, today I'm going to be talking about what I did, why I did it, the tools I used, the process it took to create, some of the difficulties that arose, and conclude with a demo of the project itself. Alright, so what is it? Well, it's an SQL database paired with a custom interface application used to input, delete, and recall test problems based on the user's criteria. So why did I do this? Well, I currently work for an academy called the Oxford Language Centre as a math and English tutor. The academy focuses on language learning as well as standardized test preparation. The test prep is for high school and university students who are looking to attend or continue university in an English-speaking country. The most common standardized tests that the students have to prepare for are the SAT, the GRE, the TOEFL, and the GMAT. In order to prepare our students, the academic director, whose name is Joe Turden, has to create study binders for each test. These binders are created by taking the best test problems from various resources as well as creating unique problems to test the student's knowledge. These questions are then categorized by type, difficulty, subject, as well as other criteria. They are then arranged into their proper sections by physically cutting and pasting them. Each page is created this way, and most of the binders are over 200 pages long. This cut and paste method is how the Academy has been creating its materials for years now, and although this method works, it consumes a lot of the director's time that could be better spent somewhere else. Some of the goals or what the project aims to do are as follows. Cut down on the time the director spends creating these binders while still keeping the quality and care that is put into them. Remove most of the physical aspects through digitizing the problems. Provide the ability to instantly create an entire binder section or even custom worksheets for students struggling with certain areas. And the program will also have to be easy to use so that both the director and his interns will be able to almost instantly adopt it. To achieve these goals, I have used the following tools. Since most of the project was coding in Visual Basic, I had to use Microsoft Visual Studio's 2010 edition as a developmental tool. I used an SQL database along with the SQL Server Management Studio to build the database. I relied on the textbook Visual Basic 2010 step-by-step written by Michael Halvorson for referencing in my code. And of course, I used various websites and online resources for references when I had to research some aspect of the project that were new to me or unfamiliar to me, such as printing techniques or SQL queries. As for the process, it consisted of 5 major steps. These were meeting with the client, designing the interface and creating algorithms, creating the SQL database, coding, and of course, debugging. The first step was to meet with the client. I had to find out what the academic director wanted out of the system. We talked about many of the features that would go into the final product, but one of the features he absolutely stressed was ease. This was a major aspect to him. In order for the system to be utilized, it had to be simple to use. This meant that the problem had to be easy to input into the database. He has various interns throughout the year. They will each need to be able to use the system with very little time to adjust to the program and input problems to the database. It will usually be the director's job, along with a few of the math teachers, to review the problems and categorize them. This means that the review process can be a bit more complex, but should still be fairly simple to use. The retrieval and creation of sections and worksheets will be the job of the interns as well as the teachers. Therefore, it should be fairly intuitive and should follow a familiar setup to a normal Windows application. Printing should behave just as it does for other applications. This should include the ability to have a print preview page. The next topic I discussed with the director was the criteria that was to be used to categorize the problems. We came up with 51 defining attributes by which a problem can be classified. This includes a variety of traits ranging from something as simple as difficulty level to more complex ideas such as solution styles. Thankfully, standardized tests don't change their question types often, so the topics they cover are fairly static and only change slightly from decade to decade. We then talked about the implementation of the criteria system. He was adamant about having a system that can tolerate multiple users, so the criteria had to be displayed to the user in a way that was both easy to ingest and comprehensive. Another concern was avoiding data loss through variations of criteria names. For example, if a user enters the word percent or percentages or even the percent symbol, the system has to either identify that or have measures in place to prevent that from happening. When it came to design, most of the work was done with pen and paper. I first outlined the user interface for all of the screens I thought I would use. At around the same time, I created a feature list of things that should be included. A few of the algorithms were sketched out in pseudocode to see what would work. Throughout the whole process, I took notes on things such as sample code and reminders to fix bugs and functionality issues. After designing the aspects of the project, I proceeded to create the database using the SQL Server Management Studio. This is my first time using the Management Studio, but I had experience with SQL before. Thankfully, it closely resembles Visual Studio, so it didn't take very long to get accustomed to. The database itself is a fairly simple one. The defining criteria are all attributes of the specific problem, with the problem ID being the primary key. Characters, integers, and images were used as the data types to store most of the complex characteristics of a problem. And for the sake of simplicity to the user, the rest of the criteria had a data type of bits. This allowed the user to input criteria based on simple checkboxes in the interfaces instead of using a tagging method that could result in data loss. Undoubtedly, coding was the core of the project. It is the most time-consuming because of the amount of time spent researching, designing, writing, and debugging. For this specific project, the coding took a majority of 4 months. This was also the most difficult part of the project. Although I have worked with Visual Basic in the past, I have never integrated an external SQL database or worked with a printing mechanism for it. These proved to be some of the most difficult aspects of the project, and I will go a little more into detail later on. Anybody who has written code before will most likely tell you that debugging can be one of the most stressful aspects of a project. This was no different for me. Small mistakes in code can put a project on hold for hours or render a program inexecutable. Also, the code is 90% of the project. It is the backbone and will determine the success or failure of everything. Although the project is mostly code, I'm only going to go through 2 examples. These mostly have to deal with the SQL database and the displaying of the results. Here we have some examples of the code, specifically the query builder. Since the user is not expected to be able to create their own SQL query, the program prompts them with the options to define the characteristics of the problems they want, and then based on their response, a query is constructed and applied to the database. Here the code is reading from the 3 specific types of user inputs, which are text boxes, combo boxes, and checkboxes. It goes through the input fields and based on their states, concatenates strings to create an executable SQL query. This last part has the results pulled in a random order and passes the string along to the next form. The next example of code is what actually pulls the results from the database. The first step is to connect to the database. This takes the string created in the previous code and using it collects the problems. These problems are then individually placed into a dynamic table and published to the form. The code will then go through and, based on the ideal size, format them so that the problems display neatly on a newly created worksheet. This also includes formatting the form to fit tightly around the problems. As I mentioned earlier, the debugging is one of the most stressful parts of the job and can take up a large amount of time. It's an ongoing process. New code has to be executed often to ensure that it won't crash the program. Sometimes a loop won't break, or the code you think should work doesn't, and the cause will often be a small typo or that you've been simply looking at it for too long, and the true problem is something very obvious. Making sure that the user can't make the program crash is a part of the debugging and error handling. Because the user has to enter data into the database, the data must fit the data type assigned in order to function. All of the user-filled data for this project handles users' errors and will either not allow it or prompt them to change it. Another ongoing process is making sure that the code is legible, commented, and follows widely accepted formatting rules. This is helpful while working on a group project, but still very useful when looking back and trying to understand your own code. Cleaning and commenting the code allowed me to jump onto a form I haven't worked on in weeks and add functionality without missing a beat. Due to its nature, the debugging process took up just as much time as the coding, if not more, and really helped me create a solid program. While most of the work for the project went fairly smoothly, there were some unforeseen problems in some unexpected areas, most notable of which were the database and the printing results. One of the first problems I came across was finding out a way to have the users pull results from the database while having no knowledge of SQL queries. A few ideas came to mind, including having multiple drop-down menus or text boxes with autofill features. These ideas were disregarded early on, and a checkbox system was put in place to simplify the user's experience. I talked a little bit about the code for the solution to this problem earlier, and will show you how it was implemented during the demonstration. Once the query was created, it took a bit of time to find out how to pull the images from the database. As I mentioned before, this was my first time using an SQL database in a VB project, so it took some time to figure out. This aspect was not so much a difficulty because it wouldn't work properly, but because it was something that I had to research very heavily. The last part has to do with presenting the data that was gathered from the database. This data had to be neatly organized and had to account for the different sizes of the problems. This ties into the last point because the images had to be pulled from the database, one by one, and modified to fit nicely onto a form. Again, something I wasn't familiar with. Printing was something that I took for granted and didn't expect to have such trouble with. It's also a crucial aspect that, if it didn't work, would render the entire program useless. Remember, the major goal here was to create a tool that will instantly create and print new worksheets or sections for binders. To begin with, printing is something that I have had very little experience with in any language and absolutely none in Visual Basic. However, I had done some preliminary research and felt confident that it wouldn't be much of a problem. The major issue that occurred was that all the research I had done was for printing fairly static forms or text boxes. Printing simple images or text can be handled relatively easy in Visual Basic by only 4 or 5 lines of code. My program, on the other hand, would not know how many images I had to print because it all depended on the user's query. It could be just one or it might be hundreds. In addition, most of these images varied in size and had to be scaled to fit nicely on single sheets of paper without being cut off. At first, I tried printing the form, which would essentially print out a screenshot of the form and didn't take into consideration that each problem was a single entity, so it would print out half of a problem on one page and the other half on the next page, sometimes cutting important charts in half. The solution to my problem was to feed every image into the print functionality individually and have it measure its dimensions to see whether or not it would fit on the page or if a new page had to be created. This sounds simple enough, but the implementation took quite a while for me to get down perfectly. Once I had everything looking nearly the way I wanted it on the printout, I noticed that some of the larger problems would overlap or they would spill over to the left or the right margins of the page. I couldn't use the same layout manager I had used to create the form from which the printout was coming from due to some restrictions with the printing functionality. So I had to write some code to scale the images to the page dimensions and add padding to each image to stop the overlap. In the end, I managed to get the printing functionality working, but was surprised that this was the most difficult part of the project. The other parts were difficult as well, but this one overlooked area just proved to be exceptionally frustrating and time-consuming. Alright, so now I'm going to show you the project in action and expand upon some of my points I mentioned here.